Hello, dear students. I am Samir Velankar and I welcome all of you to this another video on graph data structure. In the previous video, we saw traversal method called depth first search traversal or DFS. Now in this video, we will see procedure for the second traversal technique of a graph, which is called as breadth first search traversal BFS. So let's see what is BFS procedure on this given graph. Now the graph has 6 vertices and it is weighted, sorry, it is not weighted. There are no weights for the edges and it is undirected as there are no directions to any of the edges. So it is undirected, not weighted. How do you do BFS on a graph is? We typically start BFS procedure from vertex 1. But remember there is no such rule like that. You can start BFS, maybe you can start BFS from 6th vertex. Because in a graph, there is nothing called a root node or a node characterized as leader of other nodes. So a, a person can start tracing BFS from vertex 3 maybe. But in our examples, we will always start the BFS traversal from vertex 1. So what do? You start processing 1 means you print the information of vertex 1. Let's print 1. And as soon as you print 1, we will mark it as visited. Now, visited means we are going to use some sort of flag in our algorithm, which will be 0 if the vertex is not visited, and it will be made 1 as soon as the vertex is visited or printed. We will see all these issues when we see the algorithm. Now what? The next thing is, after printing 1, we will see who are the neighbors of 1. Now, neighbors or adjacent vertices of 1 are 2 and 5. They are 2 and 5. These only 2 vertices are neighbors of 1, isn't it? Then we print all the neighbors sequentially. Now, usual practice is that when we print the neighbors, we print them in increasing order. We print from least to largest. You won't be wrong, I am saying. If you say 1 after 1, we print the neighbors as 5, 2. So first we print 5 and next we print 2. There is no such rule. Even in DFS, I said that among the neighbors, you take least numbered neighbor. Always I was emphasizing on that point. But let me tell, there is no such rule actually. But the important thing is when we will see the algorithm will have some sort of for loop to check the neighbors. And in the for loop, we will ask, is 1 a neighbor, is 2 a neighbor? For loop will go in increasing order, isn't it? So obviously, the first neighbor captured will be the one which is having least number. Anyway, but I repeat, now the neighbors of 1 here were 2 and 5. And what BFS says is print all the neighbors. So 2 and 5 are printed. After printing 2 and 5, we will mark 2 and 5 as visited. Okay, now what? After printing 2 and 5, among the neighbors of 1, which neighbor was printed first? The neighbor printed first was 2, isn't it? So now we consider vertex 2 and we repeat the process on 2. Now what's the process on 2 is, see the neighbors of 2. Now neighbors of 2 are 1, yes, 1, 3, 3, 4 and 5. Neighbors of 2 are 1, 3, 4, 5. Then print all of them. Yes, all the neighbors of 2 will get printed. But you should print only those neighbors which are not yet visited. Now, among the neighbors 1, 3, 4, 5 of vertex 2, 1 and 5 are already ticked. So you print rest of the neighbors from least to largest. So the better output will be 3, 4. I hope you are understanding. After 3 and 4 getting printed, we'll mark them as visited. Now you see this list again, which I have written in red. In the BFS, after printing 2, which vertex was printed next? It was 5. So now you repeat the process on 5. You see who are the neighbors of 5, you will check. and print all the neighbors. Of course, you will print only those neighbors which are not yet visited. So, who are the neighbors of 5? Let's see. Neighbors of 5 are 1, 2, 4, and 6. Now, among these 4 neighbors, you should actually print all of them. But 3 are already visited, 1, 2, and 4. So, you can't print them again. 6 is the only neighbor of 5, which is not yet printed. So, you will print 6 and you will mark 6 as visited. All right. Now, after printing 5, which vertex did you print or visit? It was 3. So you repeat the process on 3. What is that? Repeating the process on 3 means go to all neighbors and print them. But the neighbors of 3 are 2, 4, and 6. And you observe that all the neighbors of 3 are already visited. So you can't print any new vertex from 3. You can call it as dead end, but no use. Dead end term is used always in the case of DFS. By the way, 3 does not have any pending neighbors, we can say, which are not yet visited. So after 3, which vertex did we print? It was 4. So now we will see who are the neighbors of 4. Can we print any of them? But whatever are the neighbors of 4, which are 2, 3, 5, and 6, all of them are visited. So you really can't do anything with 4. You can't jump to any new vertex. And the last one is 6. 6 was printed last. So any neighbors of 6 which can be visited? 6 is having adjacency to 3, 4, and 5, but all these neighbors of 6 are already done. Now, anyone pending in the list or no one pending? That means the output that we have got, the list that we have got, is the output of BFS for this graph. Okay, I hope you are getting it. Let's do it very fast on this graph. What will be the BFS on this graph? Print 1, mark it visited. See the neighbors of 1. Neighbors of 1 are 2 and 3. Print all of them because none of them are visited. That's why you are printing them. So 2 and 3 are printed, but mark 2 and 3 as visited. Now, among these neighbors which you printed, take the first one and process it. So you have decided that in the list, after printing 1, you saw the neighbors of 1 and printed them, but among the neighbors, 2 was printed first. So you take this vertex 2 and see the neighbors of 2, but you can see that 2 does not have adjacency to any of the vertex. 2 does not have outgoing arrow to any of the vertex. So you can't go to any new vertex from 2. So you take the next vertex which you printed, which is 3, and check the neighbors of 3. Neighbors of 3 are 2. You can see you can go from 3 to 2 and 3 to 2. But 2 is already visited. So you can print the pending neighbor, which is 4. Now 3 is also done, 2 was done, 3 is done. Now you will take the next vertex which you printed, that is 4. But when you see the neighbors of 4, or whoever are the neighbors of 4, it is understood that all of them are already visited. And now none of the vertices are pending. So this is the BFS output of the given graph. Okay, let's revise this by using an example. I am drawing some arbitrary graph. Believe me, even I don't know what I am drawing. So let's say I have a graph like this. Some undirected graph again of some number of edges. Okay, nine vertices and many edges. So what will be the BFS? Print 1, visit it. Correct? See the neighbors of 1. Neighbors of 1 are 2, 3, 4. And preferably, I say, there is no such rule, I repeat. Preferably, print them in increasing order. Now, note 2, 3, 4. None of them are ticked, so you can print them. 2, 3, 4. Now you can tick 2, 3, and 4. They are visited. Now, among the printed vertices, 2 was printed first, isn't it? 2 was printed first. So repeat the process on 2. What is that process? See the neighbors of 2. Neighbors of 2 in the picture are 1 and 5. Actually, we should print all the neighbors. But among 1 and 5, 1 is already printed or visited. So you will print 5 and mark 5 as visited. Mark 5 as visited. Now the next vertex that you printed was 3 in the list. So you process 3. Who are the neighbors of 3, by the way? 1 and 4. And both are visited. So 3 doesn't give us any new vertex in the output. Now you consider next vertex that you printed, which was 4. So who are the neighbors of 4? Neighbors of 4 are 1, 1, 3, 6, 7. But among the neighbors, 1 and 3 are already printed. So print other neighbors, which are 6 and 7. 6 and 7 are not yet ticked. After printing 6 and 7, we will mark them as visited. I hope you are getting it. Now the next vertex that we visited was 5. So repeat the process on 5. But among the neighbors of 5, you can see 2 and 6 are neighbors of 5. Both are visited. So 5 will not give us any new vertex or new output. So we take the next vertex, that is 6, isn't it? Okay, who are the neighbors of 6? 4, 5, and 8. Among that, 4 and 5 are done. So you will and you will mark 8 as visited. Now the next vertex in the list is 7. So you process 7. But you can easily see all the neighbors of 7 are done. So next vertex is 8. So you will process 8. If you see the neighbors of 8, among the neighbors which are 6, 7, and 9, 9 is still pending. So you will visit 9 and mark it as visited. But then, when you will try to repeat the process on 9, any neighbors of 9 on the taking? But you can see there is only one neighbor of 9, which is 8, and it is already done. And absolutely nothing is pending in the list now. So this is the output of BFS. Now, the very cautious and very attentive listeners might have already found that BFS algorithm will inherently use Q, first in, first out data structure. It will use FIFO data structure. Whereas DFS is inherently using stack because it is recursive. We are going to design a recursive function for DFS. More about these algorithms in the coming videos.